Hello, my name is Yerman Garba. Welcome to the short version of this demonstration of the Pessimistic validation project. The goal of this project was to allow optimistic rollups, such as the current setup for Rollkit, to IBC over to, for instance, a Cosmos chain that has its own validator set without having to wait for the dispute period in a safe way. So currently you would have to sort of trust the sequencer, which is potentially not that safe and could cause a lot of problems. So what we want to do instead is to have the validators of the receiving chain, have some of them, a partial set, validate the rollup. So they don't need to be actually validating and signing up, doing anything on the rollup itself. They just need to run the full nodes, a full node of the rollup, and sign off on the headers and the heights that they see, and that they validated themselves. So it's pessimistic because they actually verify the entire chain. They run all the blocks and all the transactions themselves and see that there are no frauds. There's what the sequencer is saying is correct, app hashes are correct, and then they update through using vote extensions. They update a light client, small custom light client called Pessimistic Light Client, with those heights. The Pessimistic Light Client depends on, and you can sort of see that a bit here, the Pessimistic Light Client depends on a regular light client, for instance, a Tendermint light client in our case, to check the proofs and all of this. So it's basically it's a quite thin light client, but that is depending on using the regular light client plus the validator set to verify. So you just do client updates between the rollup and the chain through the regular sort of light clients, Tendermint for instance, and then you have the IBC packets actually going from the regular light client to the pessimistic one, and that's how you get the safety. I have not implemented any way to actually stop these two from creating channels over here, which might be okay because like the tokens that you would send over, you would not necessarily, then they wouldn't be the canonical ones and you wouldn't necessarily trust them or have any use for them. I've also thought about how to solve that. You can put use some IBC middleware or something like that to actually stop those things from happening. The other alternative is to sort of flip the dependency here and add a way for the regular light client to actually depend on the pessimistic light client. So I think the IBC implementation is actually looking at how to implement something like that, because it's needed for because like the pessimistic light client should probably also look at data availability from Celestia to make sure that this has actually been the data is available. So there's a bunch of things like that. And yeah, there's a lot of information in the README here, both on the shortcomings, a bit on economics, some alternative solutions, another alternative solution that is more similar to the eIBC one. And in the code here, you can find the hub chain, which has two important things, which is the pessimistic module. So that's the validation objectives where they sign up for the light client, the pessimistic light client. And in the app here, you can also find the vote extensions. So basically, reading the validators read their own full nodes, vote on them, and if everyone agrees, then we basically put it as a light client update. And then we have a rollup, which is almost vanilla. It just has a couple of modifications to allow for our light client to work. And there's a full end-to-end test using interchain test, which has also been upstream some changes here for this to actually work. because there's a lot of sidecar stuff with Celestia and stuff like that that's was not working out of the box, but it's working now. Yeah, and this does the whole thing end to end and verifies that it works. And in addition, there's another demonstration video that's is longer, where I go through all the steps here, where you can try it yourself as well. So there's a Docker compose that spins up everything except the relayer, and yeah, you need to use my own fork of the relayer, of course, because there's a lot of forks here and there to make this work, but it's just small hacks. So most of it can be upstreamed or easily resolved. And that's pretty much it. There's some other stuff here, some half-baked relayer and stuff, but it's not so important. The point is mostly the pessimistic implementation here. So that's it. Thank you for the attention, and